guys from Hill, and today I'm going to be talking about dredge pump performance. So a little bit of background. If any of you don't know what dredging is the process of moving sediment from the bottom of the waterway and placing it either on land or back into the waterway. There's a couple different uses for dredging. There's land creation, ship channel deepening, and land restoration. I have worked for a company called Weeks Marine for the past 3 years. It's a dredging company, and it's one of the top 3 dredging companies in the country. This past summer, I worked on a land creation project. Does anybody know where Ship Island is in Mississippi? Well, it used to be East Ship Island and West Ship Island, and now it's all one big island, which was done by a competitive company. And then this past summer, we actually widened it by about 6 feet and raised it by about 2.5 feet. And our company actually accounts for about 65% of the marsh restoration along the Gulf Coast. So there's 3 main types of dredges. There's a hopper dredge, a cutter dredge, and a clamshell dredge. Basically a hopper dredge, it has either 1 or 2 drag arms that come off the side of it. It's self-propelled. It just propels itself. It drags along the bottom of the waterway, and it actually loads itself. And then it takes, so this is actually our newest dredge, the Magdalene. On the front, it has a discharge valve, and so it fills up in the middle, and you connect to a pipe, or you can actually put a spray valve on there, and that's how they do a lot of beach restoration jobs. They just spray the sand onto like the Palm Islands and UAE. A cutter dredge just has a telescoping big cutter head. It's about 8.5 feet tall, and it cuts and it swings. So you put anchors out on the side. It's not self-propelled. It actually has a tug that tugs it, and you telescope it down to the bottom. The head spins, and you swing. There's these 2 things on the back called spuds. You pick one up, you put one down, and it walks. So you pull the anchor, it steps. You pull the anchor, it steps, like that, and that's how it does. Clamshell dredge is just basically a crane. Goes to the bottom, scoops it up, flows it onto a barge. So, like I just explained, the one on the left is the cutter head, and the one on the right is the drag arm. Those are the 2 I'm going to be talking about today. So they both use a type of centrifugal pump. So the cutter head has a telescope, and it sucks it up into the suction. It goes through a pump, and it discharges out into a pipe of some sort. So when we talk about pump performance, it uses similar to a propeller. It works in the opposite fashion, and it combines angular momentum and mass conservation equations, and you get the ideal head equation, and that is the big velocity squared over gravity minus your propeller velocity in the cotangent of beta, and beta is your tangent velocity, the angle from the tangent velocity of the blade. So when you plot your ideal head, you should get a linear line, but we know that you have a lot of losses due to friction and other losses, so you get a line that's not so linear. So to find your power and efficiency, your ETA is your water horsepower or your brake horsepower. Water horsepower is just, it's like wheel horsepower in a car. It's the amount of horsepower it takes to move water. And then that is the specific gravity of the fluid you're pumping times the flow rate times your dynamic head over 550. And your brake horsepower is your torque shaft times the angular velocity of the torque of the shaft over 550 and converted to RPMs to 6 CL/SI. So then, this is just saying that another quantity we like to use your net positive suction head, and it's the amount of head above the vapor pressure, and this avoids cavitation, or it avoids when you want your pressure to stay above this pressure to keep it going. So when you plot all three of these on a graph, this is what you get. And then you use your energy equation to solve for your system and how you plot your system curve onto these graphs, and you typically want to find your operating point at the highest efficiency. So this is actually the typical performance of a 30-inch cutter dredge. So this is our newest cutter dredge. It's a 30-inch cutter, and it has a 3,000 horsepower electric motor. So if you plot the 3,000, so here's 4,000, here's 5,000. So if you plot the 3,000 line, and if you want the greatest efficiency, depending on how deep you're going, so how much head you have. So say you're plotting it here, you want your highest efficiency at 89. Say you're digging about 180 feet. So you want to have a flow rate of around 5,000 gallons per minute, and you want to keep it at above 250 RPMs.